Good afternoon. My name is Leah Martin with NASA's Office of Communications, and thank you for tuning in today to today's NASA Social. GOES-U will launch tomorrow afternoon on June 25th at 5:16 p.m. Eastern Time from Launch Pad 39A. At least that's the time we're targeting. This GOES-U mission is the fourth and last of the GOES-R series of geostationary weather satellites operated by NOAA. Today's audience is a group of digital content creators who are visiting NASA's Kennedy Space Center for a NASA Social, which includes a behind-the-scenes tour of the center and our operations, as well as some of our critical facilities, and today, an opportunity to learn more about the mission from this diverse panel of subject matter experts that are here. Guys, thank you so much for joining us today. I'd like to introduce you to some of the SMEs who are here to teach us a little bit more about the GOES-U mission and hardware that's on board. To my left here, we have Ramirez, who is the Deputy Division Chief of the Mission Operation Division of NOAA. Jade Zsiros, the Mission Telemetry Engineer with the Launch Services Program here at NASA. Dakota Smith, the Satellite Analyst and Communicator with NOAA. And then Allana, Nepomuceno, let me see, I'm going to do that one more time so we can get it right. Nepomuceno with GOES-U. She's an Alto Senior Manager with Lockheed Martin. And then finally, Reith, the Advanced Baseline Imager or ABI Program Manager with L3Harris Technologies. Guys, thank you so much for joining us here today. We have a lot to learn. We have a lot of questions to ask, and they'll be taking them live, both here in our studio and then also from our online audience. If you are tuning in today and you have a question for our panel, you can ask using #AskNASA. So we're going to kick this off with some opening remarks. Ellen, let's start with you and tell us a little bit about your role with NOAA.
Good afternoon, everyone. Ellen Ramirez. I'm the NOAA Satellite Deputy Chief for Mission Operations Division. We're responsible for the daily command and control of the NOAA fleet of satellites. So this includes ensuring the on-orbit health and safety of the spacecraft, as well as providing flight engineering services for when an anomaly is underway. So after GOES-U launches and it concludes its post-launch test and checkout period, it'll be handed over to NOAA, where we'll perform the 24/7 command and control. As for my background, I am a meteorologist and atmospheric scientist by education. I've worked in NOAA for about 13 years. It's partly been in the products and services realm, doing hazards and disasters monitoring from the sensors aboard the satellite, and now I'm on the flight side for operations and engineering.
Oh my gosh, what an exciting role you have. You normally hear of meteorologists and you think of someone who's on TV, but man, you do so much more than that. Jade, you're the Mission Telemetry Engineer with NASA's Launch Services Program. What does this mission mean for everybody involved here?
GOES-U is an incredibly important mission for a huge number of people for a variety of reasons. For one, the rest of the GOES series launched on ULA rockets, but this is the first GOES satellite to launch on a Falcon Heavy. We're really seeing how all of these companies are able to come to NASA's need effectively to be able to put these science missions in space. The Launch Services Program here is responsible for launching primarily NASA's science missions, and we are also responsible for observing and helping and listening to the needs of our commercial partners such as ULA and SpaceX, and the whole GOES program has been so important to us.
Thanks so much, Jade. And Dakota, as a satellite analyst, how excited are you for this launch and for the information that we're going to get and the imagery that we're going to get? Can you tell us a little bit about that?
Yeah, I mean, personally, it's my first launch, so I'm really excited to see a satellite go up. The imagery is going to be amazing. I mean, we've seen the 3 previous GOES satellites give us this amazing high-resolution imagery, sort of game-changing for weather forecasters. My area expertise is making the imagery look pretty and work with media folks and government organizations to give them imagery. So I'm really excited just to look at it, and I don't know. I think weather is fascinating. So every high-res view we can get, I'm very excited for that. So.
Well, I think with this being a part of this network that we have, I think you're probably going to get some really amazing images and be able to tell us a little bit more about the planet that we live on. So we're excited to hear about that. And then, Allana, can you tell us, NASA has partnerships with many different companies, and then specifically working now with Lockheed. Can you tell us a little bit about your role and then what you're doing to contribute to this mission and kind of help NASA and NOAA with the work that we're doing off planet?
Sure, yeah. So my role is a senior manager for ATLO. ATLO is the Assembly Test and Launch Shops organization. I think I have the coolest job because we get to interact with the hardware every day. So what my team's responsible for is integrating and testing the satellite to make sure that it's ready for operations when it gets on orbit. So we fully put it through its paces while it's down here on Earth, testing all the functionality of the satellite, making sure it's going to survive a launch, making sure it's going to survive the space environment, and then function as it's needed to get those cool images back that you were talking about.
Incredible. Thank you so much. And then, Chris, you work with the Advanced Baseline Imager, or ABI. Can you talk to us a little bit about the mission, the expectations, what we're hoping to see, what we're hoping to get back, and kind of how we'll be using this?
Sure. So we're very excited for GOES-U and the launch of the 4th Advanced Baseline Imager. The Advanced Baseline Imager provides imagery across 16 channels or colors. So a lot of the products that are developed by and delivered to the forecasters are developed by are sent to us by the Advanced Baseline Imager. But L3Harris also plays a role in the enterprise ground system. So also, as the provider of the ground system, we provide the data processing and distribution of the products to the forecasters, which has really been a game changer for them.
Incredible. Well, I'm sure that you listening online and then you here in the room have plenty of questions. So we're going to go ahead and kick off our Q&A. We'll start here in the room. If anybody has a question, just raise your hand. The handler who can come over to you and get you a mic. Right here.
I just wanted to know how you went about testing the satellites on Earth. You know, given the conditions are completely different. Obviously, the satellite's like something like 23,000 miles up. Obviously, you can't get that sort of range on Earth. So I was wondering how you went about, you know, kind of stress testing that sort of thing.
Sure, I'd be happy to
talk
take that
about the
question.
range part?
Yeah. So I'd be happy to take that question. So the instruments and the satellite both go through a very rigorous testing regime that very closely resemble the environment of space. So first off, we're going to send it through a vibration testing that's going to shake the instrument and simulate the vibrations that it'll feel when it's launched and put into orbit. And then we'll take the instrument and we'll put it through a thermal vacuum chamber testing, where we will suck all the air out of the chamber as it is in the vacuum of space, and then we'll send the instrument and the satellite through a series of hot and cold cycles that those instruments on the satellite they'll see in a daily cycle in the geostationary orbit. And then finally, we'll send it through some electrical testing and some electromagnetic interference testing to make sure that the instruments aren't interfering with the other instruments on the spacecraft. So all the instruments and the spacecraft go through a very rigorous environmental test campaign, which takes several months and is very rigorous and is witnessed by NASA and NOAA along the way.
Thank you so much. Next question right here.
I would love to know what makes the GOES-R series, and particularly the GOES-U satellite, unique compared to other weather satellites that we have out there, and maybe not just U.S. satellites. Is there anything comparable, or why is this different?
I can start with this question. So there is something unique on the GOES-U spacecraft that's different from the GOES-R, S, and T satellites that are the other three in the series, and they're currently on orbit. And that is that GOES-U has a new instrument called CCOR. It's an acronym CCOR. It's a compact coronagraph, and it's the first of its kind. And its mission is to measure the outer atmosphere of the sun to monitor for coronal mass ejections. So when we can detect these being directed towards the Earth, that is when our Space Weather Prediction Center at NOAA will start to send out warnings to the general public about potential disruptions in comms, power systems, navigation, things of that nature. So that's our first early warning detection and a new instrument on GOES-U.
Next question right here.
Question for Dakota. What features in satellite imagery have you found are most popular among media and on social media?
So the high-res views are probably the most popular thing, the 1 minute high-res views that we get, visible imagery. The lightning imagery is incredible, and people really seem to like that. Anything that brings context that looks like a real weather event, like say a hurricane out in the middle of the ocean. A true color view of a hurricane can really mean a lot to someone who may be hearing about it through their weather forecaster or their meteorologist on air. So actually seeing these high-res views of a main weather event, I think means a lot. And then the fire temperature imagery that we've had recently has also been very popular, especially with news folks. It makes the fire look sort of compelling and very interesting. So yeah, those are just a few. I could go on and on.
Thanks, Dakota. We have a question. Mike Ashby on X asks, will GOES-U be used for wildfire detection globally?
I'm happy to take that one as well. So the GOES-U satellite, once it reaches orbit and it goes through that very rigorous test checkout process, first that occurs on land, and then when it's on orbit, it takes about 6 months until it's handed over to NOAA. It will be monitoring the GOES East footprint. So that roughly extends from the west coast of Africa over towards the western continental United States. There is geostationary imagery that's pictured together that captures all around the globe. But for NOAA, we have an operational GOES East, which will be what GOES-U eventually becomes. Then there's an operational GOES West. We have partners over in Europe at the European Meteorological Space Agency called EUMETSAT. They operate two. And then there is another geostationary sensor operated by JAXA in Japan. So that creates the complete picture of the globe. But for GOES-U, it will monitor and pick up on fire hotspots, and it'll be used for fire detection as well as smoke monitoring, but for the GOES East footprint.
Excellent. We'll go back here in the room, but as a reminder, if you're watching online and you'd like to ask a question, just use #AskNASA. We'll go right here to the front.
I have another question about the solar coronagraph. One of the challenges with looking at these coronagraphs is understanding the direction of the coronal mass ejection. Does this new instrument tell us definitively whether or not it's Earth-facing or a backside event when we see these images?
There is information about a vector, and so yes, we will be able to determine if it's Earth-directed or else.
And then I think we had one other question here in the front row.
I'm curious about the propulsion system that takes it and sort of like locks it in place out there. And then does the satellite have to unfold and, you know, it's like it's packaged in this capsule? How does that process work?
Yeah, I could to that a little bit. We have the model down here. So on the bottom, you can kind of see the black portion that sticks down there. That's called the liquid apogee engine. So after the rocket drops us off, the liquid apogee engine is what takes us the rest of the way out to our final orbit, so through a series of burns once we're out in space. Then there's some smaller thrusters. Some are kind of hard to see, but they're the small silver items that are sort of hanging down from the bottom and off around the side. Those are minor thrusters that we use once we're out on orbit, just for repositioning and kind of station keeping when we're there. And then, yeah, as you mentioned, it does not launch on the top of the rocket looking like this, right? We've got to fold it up. It's got to be nice and compact to fit up there in the fairing on the top of the rocket. And so these items deploy when we're out in space. The solar array deploys fairly early, at least the first 4 panels, so that we can get power to the satellite, and then other items deploy later on in the flow.
Thanks so much. Okay, we'll take one more question here from the room before we hop back over to social. Questions? Here in the front row.
I can wear my invisible microphone. What is the expected lifespan of the GOES 19? What's in geostationary orbits?
I can take that one as well. So for our GOES-R series spacecraft, the 4 of these will carry us into the early 2030s and beyond. There is a follow-on mission that is already being planned called Geo Extended Operations, GeoXO for short. That first satellite is planned to launch in the 2032 timeframe, but GOES-U lifetime will last several years after that point, so mid to late 2030s.
Thanks, Ellen. And let's see, Jade, I think this one might actually be for you. Moosey on Instagram wants to know, why can't it use a Falcon 9 as its launch vehicle? Can you talk to us a little bit about the vehicle it's launching on?
Yeah, so in the Launch Services Program, the primary role that our whole program has is to match a satellite or other spacecraft to a rocket and then guide both groups, that is the spacecraft group and the launch vehicle group, through the process of helping their engineers work together, finding a place for their spacecraft to be processed, getting the engineers from both companies as well as our engineers into the same space to converse about their needs. A Falcon 9 simply is very, very close to the weight limit that GOES-U required. We actually could have launched it on a Falcon 9, if I remember correctly, but it was a little bit too close for comfort. We were also, at the time that this was being discussed, we were in the process of really nailing down the certification for a Falcon Heavy rocket. They were already on ramp for what we call the NLS-2 contract, which is what allows NASA to pay SpaceX for launch services. However, SpaceX wanted to show that they could do a GOES-U, a GOES mission, and so they campaigned very hard, and they made us a great deal. They showed us that they were going to do these certain things for us for a certain price, and they said, we really want this mission because we want to prove that the Falcon Heavy is ready for bigger and better things. For the Launch Services Program, we want, a certain number of successful launches with things like weather satellites before we're willing to, for example, put people on it. And GOES-U, of course, we always prioritize the safety of the satellite, but we would rather launch a GOES satellite before we put humans on the Falcon Heavy.
Thanks so much, Jade, for walking us through that. We do have another question we'll take from X. Juan asks, will this make long-term hurricane path and development forecast more accurate this season? That's a great question for us here in Florida. Who on our panel would like to take that one?
I think the short answer is yes. Yeah. Sorry, if you want. Yeah. There's the high-res data really helps. The lightning data really helps. It is it's a long-term process. This imagery, the data that we get does make our models better, both short-term and long-term. But yeah, it's a long process. A lot of research that has to go into it. You had another comment?
No, I agree. It will. It provides the more data that we can get, right? is going to be better. We're imaging, new phenomena all the time from the weather science, and so getting this up there, and with the addition of SEACOR, more opportunity to see new Earth science features or Earth weather as well, and just better understanding there. So agreed.
Thanks so much. Okay, I think we'll come back here to the room. Any questions up here, front row?
With all of the data that you're collecting, I imagine it's a massive amount of information to sort through. So are you using any kind of like AI or machine learning in order to filter through a lot of that data? And then what matters to just the common person that's worried about weather and how it impacts their life?
So that data is called telemetry. So as the mission telemetry engineer, it is my job, between launches, it is my job to write software that processes all of that data and makes it available to the engineers who are sitting on console for these launches. We may have people who are specializing in propulsion, and there may be a team of several dozen people working together looking at diagrams, and these diagrams may have associated measurements, associated sensors that we receive the data from. As the mission telemetry engineer, I write software that allows them to plug in the name of this sensor and get the reading from that sensor as it is right now, or over the course of the last 5 minutes, or over the course of the last 30 minutes. So to answer your question, for one, there's a whole lot of people looking at that data. So we talked earlier about how there are hundreds of thousands of measurements coming off of a Falcon Heavy rocket, including the measurements that we're getting from the spacecraft. In this case, GOES-U has telemetry interleaved with the Falcon Heavy telemetry. But there are hundreds of people who need to look at all different aspects of those. And we have software here at Hangar AE, which is where I work, that processes the data that the engineers at Hangar AE would look at. There are engineers at SpaceX Hangar X who have their own software that look at all of that, and it's tailored to their needs. You're right. There is a whole lot of data. It takes a whole lot of software to process all of it. The cables that we need to receive that data are very, very large. I hope that answers your question.
If I may, I can just add a little bit to that. So the GOES-R series of satellites, so the GOES-U will generate up to 1 terabyte of data each day, sent from the satellite to the ground system. Then the ground system has to take that data, has to process the data, has to calibrate the data, and it has to navigate the data. So the pixel that you're looking at is exactly where it was taken on the satellite. So there's a massive amount of processing that goes on the ground when that data comes down. It's a massive amount of data, and then it has to actually be sent back up to the data and actually rebroadcast. So there's a lot of processing that goes on both here in the ground and in the spacecraft.
I can add on to that as well. So the previous series of satellites is what we call GOES-NOP, our legacy series, and the premier instrument on board, that advanced baseline imager that we have now, before it had 5 channels of information. In the current series, which does include GOES-U, has 16 bands of information, so it's gone up by a factor of 4. NOAA is responsible for the archive of the data and products that come down. That's done by our National Centers for Environmental Information. And in terms of how we catalog everything, there's a migration effort to the cloud that's underway. Instead of using on-prem legacy hardware, we're moving to a cloud environment.
I have a go back. I'm so sorry. I forgot that you asked about AI and whether we were using AI to process this data. At this point, we are still investigating what can be used most safely. Obviously, AI is extremely powerful, but it is of the utmost importance that no important data is missed. Right now, we have a system that works, and obviously, we always want to be innovating, but the safety of the rocket and the payload comes first and foremost. We are currently exploring AI tools, which will be used in partnership with the human engineers, but we will certainly not be replacing human engineers in the foreseeable future.
Man, what a great reminder that it takes so many people working together to get what we need from these missions. And I saw a hand right here. We have a microphone coming your way. Here we go.
Hi, how do you communicate with the satellite once it's at its new home?
Do you want to take that?
So okay, I can do my best at answering this question, but the spacecraft communicates with the ground with several antennas. I believe the data is coming down through the X-band antenna, if that's correct, and so that's the primary means for how the data is coming from the satellite.
So I'll add on to this one too. So NOAA has the 24/7 command and control of the satellites. So it's signals going up and then coming down in the X-band. That's how we retrieve the data. We've got 2 ground stations at NOAA. We've got one at Wallops Island, Virginia, that we use for our GOES and our geostationary satellites primarily. And then another ground station up at Fairbanks, which we use primarily for our low Earth orbiting missions. But we have 2 mission management controllers that are on site 24/7, 365, the nights, weekends, holidays, and snowstorms, making sure that those communication signals are intact. We also have 2 product operators that sit on console to make sure that data products are coming down and being produced.
Thanks so much, Ellen. Jade, we have a great follow-up question. You talked a little bit about LSP and how they're kind of right-sizing those payloads to the launch vehicle. We have a question from Fun Awesome on YouTube, and he asks, what is the weight of GOES-U compared to the max weight Falcon Heavy can launch?
So, unfortunately, I do not remember the actual weight. Falcon Heavy can actually carry far, far more than the weight of this payload. I wish I remembered what that value is. What?
Over 11,000 pounds.
When
we're fueled, yeah.
Mm-hmm. So that was a GOES-U weighs a little over 11,000 pounds. Yeah. I wish, I believe it's a factor of about 10. But that's why we always look for opportunities to do what we call a ride share, which is where we put multiple satellites in the same payload or in the same mission. I'm not sure if GOES-U has a ride share. I actually work most of the missions, which we have one every other week or twice a week now. So I'm not sure if GOES-U has a ride share, but we try to prioritize, efficiency. We try to put whatever combination of items that are in that space, that are on the top of that rocket, is the most efficient, smartest, safest combination of items that could be encapsulated. In this case, if we did not put anything else with it, it's because we deemed that GOES-U really needed to be by itself.
Thanks so much. We have one more from social I'd like to cover. We have Right Dobbs on X, who asks, is GOES-U going straight to its orbital position? And if not, will there be where will it be stationed over before it drifts to the GOES East position?
I can answer this question.
Go for it.
Okay, so after GOES-U launches, we have 30 days of launch and orbit raising, and then it begins about a 6-month post-launch test checkout. We call it PLT, and that is conducted at 89.5 West. It's a parking spot that NOAA has used for several years, and we've historically done the checkouts at that location. Once the satellite spacecraft and its instruments and their subsystems and payloads have been checked out, the satellite's handed over to NOAA, so that'll be in approximately January 2025 timeframe. And at that point, we will begin a drift over to around 75 degrees west, and that will be its operational location. So what we'll have to do is we'll drift the satellite at approximately 1 degree a day, and we'll bump it right up against the operational east that currently exists, which is GOES 16. We'll have a very brief period on the order of just a few days of a dual checkout of both the satellites in the same location, and then we will move GOES 16 west over to 104.7, and we will keep it there as an on-orbit spare. And it could be activated if either the operational east or operational west has an anomaly and goes offline.
Thanks so much. think we have time for just a couple more questions here in the room. Right here, we'll start, and then we'll go over here for our next question.
So a notable thing about these satellites is the incredible imagery of Earth. And I noticed what stands out to me is the incredible dynamic range capture between the dark side of Earth and the lit side of Earth. So I'm wondering how the instrument can handle such extreme dynamic range and create such a cool photo.
I think that question's for me. I think it can handle the dynamic range of all those different temperatures that we see from the Earth by having specified bands that we actually optimize in our focal plane modules. So we have specified bands, 16 of them, on the ABI instrument that we have down here that is optimized individually for each one of them's dynamic range. They're actually within the ABI, there are 3 focal plane modules with those 16 channels, and each one of them operates at a different temperature, just so we can optimize the dynamic range that the imager is going to be measuring at.
Great. We'll go right over here to this question, and then we'll get you right after, okay?
So we've time traveled to 2044. And what does the ideal satellite look like for weather monitoring?
So if we fast forward to 2044, we will be in the era of the geo-extended operations. So we'll still have instruments that are in the current payload, like the Advanced Baseline Imager and the Lightning Mapper and several others. But in addition to that, there's going to be additional instruments that monitor atmospheric composition. So for aerosols, we'll have a new instrument called ACX, and then there will also be a new instrument to monitor ocean color for the health of the ocean. So that's what it looks like. It also means more data, more information to archive, could make it harder to process as we keep increasing in temporal resolution and spatial resolution. But that's what the geo landscape looks like. So there will be a continuity of operations. We just keep adding new features and making the imagery better and better in more high definition.
If I can add to that as well. So the next generation GeoXO will have an imager very similar to ABI, except it'll have 18 channels as opposed to the 16 that ABI has. So there'll be an addition of 2 new channels for the GeoXO imager, or GXI as we call it at L3Harris. It'll improve the spatial resolution on 7 of the channels. So those images that we're seeing, we'll see at 4 times the resolution. So that's one of the improvements that's going to come. But I think the real game changer with GeoXO will be the new observations that we'll be able to see with the addition of a sounder, an atmospheric composition, an ocean color instrument. So I think that's going to be the real game changer for GeoXO.
It's a world of possibilities ahead of us. And then we got time for one more question. We'll go right here.
A lot of my question was answered, but I wanted a little more insight into the GEO mission. Seeing as we've been told that GOES-U just outclasses its predecessors and has innovated greatly, do you project that innovation is going to slow down a little bit? Do you think you'll hit a wall anytime soon? And is the mission profile going to be the same, or it's just in geostationary orbit in that same general orbit area? How many more instruments do you think you'll be adding over the course of the lifespan of that next NOAA satellite operation?
Yeah, that's a really great question. And while GeoXO is still in its very early stages, there's an option for a partner payload if NASA and NOAA are interested in it. So but as far as the technology goes, the technology is continually changing. So keeping up with that technology is really the challenge. We're designing these instruments and these satellites and payloads now that are going to be used for the next 20, 30 years. And so making sure that we're staying on that cutting edge of the technology to make sure that it's going to be providing the best images, the sharpest images, the best forecasts 20 and 30 years in the future is really critical.
Thank you so much. It's great insight, and we have so much to look forward to. Unfortunately, that's all the time that we have for today. Our NASA social participants have a huge day ahead of them tomorrow as we put our eyes to the sky and look up for GOES-U. If you are a digital content creator and you're interested in participating and joining us for NASA Social, look for more updates for future missions on www.nasa.gov/social. Meanwhile, you can join in on the GoesU conversation leading up to tomorrow's launch by using hashtag #ReadyToGoes. I'd like to give a huge thank you to not only everybody here in the room who's participated, those of you who have watched online, but also to this incredible panel of subject matter experts who have lended their expertise to this mission and given us more insight into this really exciting opportunity that we have to learn more about what's happening here on our home planet from way out off of our planet. Our launch coverage will begin tomorrow at 4:15 p.m. Eastern Time on the afternoon, June 25th. You're able to view that live at nasa.gov/live, and I hope that you can all join us, eyes to the sky, and go you. There we go. Thanks so much.